comparing students at SPHS to students in other APES programs worldwide, SPHS APES students do better than about 85% of other populations. There are only about 10 to 15% of APES programs elsewhere that would have a better success rate than ours. You should know that for the 2 weeks before the AP test, I've prepared a pretty ambitious review plan for you, but it all happens on your own time. It's not in class. So for students who really want to study a lot, I have a lot of stuff to help you with that. And for students who'd rather not study at all, I won't force you to do any of that. Anybody have any questions for me so far? I've done a correlation over the years where I'll take the printout of the students' grades and compare it to a report of their testing average. And here it is. It's multicolored, so I'll explain for you. Think of how much you usually study for one unit exam. As an average of all students in all my classes, most students study on average right around 1 hour per unit exam. I think the average is about 1.2 hours. Does that seem fair for you? About an hour, 1.2 hours for a unit exam? That you actually study, looking at stuff? Now, imagine you multiply your own personal average by 3 or 4. So we're talking, for most of my kids, I'm going to say about 5 hours of study. That's the blue line. Find your average on my 6 unit exams so far. Find your average on my 6 unit exams. Follow the blue line. That's the grade you're most likely to get if you study about 5 hours. If you study a lot, like 10 to 15 times a unit exam, then you could possibly follow the green line. And if you study less than usual, then you'd probably follow the red line. There's a few other variables. Variable number 1 is just the luck of the draw. If we get lucky, we might get questions that are very similar to the content in this class. Every year, about one of the questions is like what we as a population are like, that's easy, we talked about it. And most years, there's a couple of questions that are kind of like, I remember that one time you said that. And usually there will be like one of the essays and some of the multiple choice where the students are like, Jose, you're the worst teacher in the world. But I've had a year when we were just not lucky, and we had like a couple of really hard questions that students did not feel prepared for. It's kind of luck of the draw, just so you know, if you have bad luck this year's exam, you could go red line down by 1. Also, if you have like personal drama, like you're sick or you got dumped or you get kicked out of the house or whatever, you could take another point off. So in order to make sure you're going to pass, unless you have an A average in my class, you'll probably want to study in the ballpark of 10 to 15 hours for this test. And if you could study double that, it really pretty much, if you're truly studying 15 to 30, that'll lock you in. Many of you have other AP tests. Many of you have other stuff going on. Totally get that. But that's my analysis of how you'll do on this AP test. Yeah?
You suggested in the beginning year that we buy like that book.
Yeah.
What's it called again?
Smarty Pants Guide to the AP Environmental Science Exam.
And that, like, if you do that,
It helps. I mean, it's just that's one thing you can do. It depends how many hours. Like, it's not a thing that you do. It's a tool that you use.
Oh.
So, like, if you're using that for, like, maybe 5 hours of your study time, that's probably really helpful. What else? No other questions? Yeah.
Jose, you're like the best teacher ever. I'm so surprised you don't have like some ridiculously high passing rate, like 99%.
Oh, if I was interested in my passing rate, I could doctor that. Like, I don't cherry pick my students, unlike a lot of other, like, I could tell you who was going to get a passing grade on my exam before the year started. Like, I can just look at your science history and your math scores. Like, I can just look at transcripts and tell you who's going to pass usually. Like, and by the way, I don't discourage kids. I got students where I'd be like, yo, dude, don't take the test, please, because you're probably going to fail. But, like, I don't care, man, if they want. Out of like and by the way, I've got 6 sections of this class. If I had one section where I could like choose the students that I know are like bone crushers, A, it would be way easier to teach, and B, I could make this like a super nerdy, really like college level class, and I'd love that. And we'd have 100% pass rate every year, no doubt. But that's kind of not what I'm going for. Like, I got a lot of kids where this is their first AP class. I got a lot of kids with like a pretty horrific science background or like no math skills. And so I'm happy to teach them, and I think it's cool that they be in the room, and I think it's cool that they learn the stuff, and like I'm psyched on them trying, and I don't discourage people from taking the test. And I'm not a very good teacher, by the way. Also, unless that was sarcastic. Yeah.
Wait, so do teachers actually like pick their classes? Like,
You can. Yeah. So like there are some schools where the teachers have like the ultimate say about which students get enrolled in their classes. And so like I've been given that opportunity before. Like, would you like to look through these transcripts to make sure that all these kids should take your class? And I was like, no, who cares? I love everybody. And then I get all these kids at the beginning of the year that are like deer in the headlights, and like we're at the second semester now where like some kids have left. Yeah. Okay, anybody else want to talk about the AP test preparations? If you read your handout, you'll notice that you can sign up late. Just so you know, like, I don't want to give you the whole lecture, but I got to be really clear. The actual deadline is March 26th. If you read a couple of bullets down, it says late registration, April 11, and then really late registration, April, and then like super final dead late, and it's like, no. All of those, like, you can still be allowed to take the exam, but it's worse for everybody. Worse for the school, worse for your peers, worse for me, and worse for you. Like, there's such a long explanation, or you can just take my word for it. Sign up before March 26th. And by the way, that last day of sign-ups, the business office is like the Kardashian butt photos in the internet. Like, this enrollment will like break the business office. That was good, right? Break the internet?
Yeah. It's a famous person in the profession. Famous person.
All right.
Yeah, I was fucking fine.
Next. Who's got solar house model questions? Ask me now. Yes?
What are the angles for the eaves and awnings?
That's
The
up to
angles of
you.
the sign.
33 and 54. They're written down on the paper.
So,
Yeah, so please look up. 33 off the horizon for winter, relatively low. 54 off the horizon for summer. 33, 54. Yeah.
So if you incorporate any reflective type of anything, even if it's not mirrors, like if it's like shiny rocks or something, would it not count? Or
Okay, so reflective houses are usually kind of a problem for neighbors. And so but you can make it white, and that's
it's not like on the actual
And separately, I've had a couple of kids tell me that they'd like to use some sort of like bouncing light to get it into the house. I'm willing to try that experiment, but I'd like to see it in your plans first, and I might not accept it. Like honestly, like it says no in the plan, in the instructions. If you want to try something, show me your idea that you'd like to try it. We'll see. Yeah.
If something in our plans like doesn't work, can we change it before we do them? Like go on with the project.
The way that this will work is you'll turn in the plans. I'll give you credit for the part I like. If it's not full credit, you can resubmit it before the model is due.
Okay, so you can like change it.
Separately, if you get credit for the plans, but then decide you want to change them before the model, you just have to bring me the new plans, and I'll regrade them. But there has to be a final version of the plans that you will attempt to model. Because the model will be measured by its ability to test the plan that we call final. So along the way, when you're starting to think about the model, you could be like, hey, I want to tweak my plans, that's fine. But when we call them final, there has to be a point where you're done tweaking them, and that's what we're going to compare the model to. Anybody else? Nobody else? You might remember that there was a day last week when I had an unexpected absence. Looking at the remainder of this week, I have to teach you nuclear chemistry and nuclear reactors and nuclear meltdowns, and then we have to study so we have to prepare for the exam. And so I'd like to postpone the date that you turn in your plans. I'd push it back.
thank you.
By 7 days. You are seriously nerds. You are. That is like the nerd exam, and you all pass. You're definitely nerds. Do you care about the quality of your work? Yeah, there you go. It's not going to do it anyway. Another week, you're not going to do it. Another week, not worry about it.
All right, time.
Yeah.
Does that affect all the other dates on the solar house? No. Are they like large enough gaps that doesn't matter?
Yes.
Yummy, please. Excuse me.
It's that thing.
I'm glad that you're happy. Good news. I hope you'll use that extra week to make your work that much better. I want to remind you that you getting an extra week is like, great, that's another week for me to think about it. But all the kids that are already doing like an A+ job, they're going to take an extra week to make it even more A+. I can redo my watercolor even bigger now. And like, since this is an assignment where everybody's going to see each other's work and stuff, like, if you show up and yours is like totally candy cane, you're like, you even had like a bonus week to do this. And almost everybody is already like mostly done. They've been working on it until everything but the last night. So even if you did leave it for the final last night to do the work, now you got an extra 7 days. There's like no excuse for crappy work. Like no excuse. Like I will be ruthless if you did a bad job. Finally, if you need to store your plans on campus, drawer for period 2 is slightly ajar in the back over there. You're welcome to use that. Any questions for me? Did we talk about geothermal last time?
Yep. Sort of.
No?
Yes.
Which is it? Did we talk about oscillating water columns?
Yeah.
We did? Did we talk about wind power?
Yeah. We ended on oscillating water column.
Yeah, we ended on oscillating water columns. Yep.
What about biofuels? Talk about biofuels?
Sort of. Nope.
We're on number 34. All right, now me. We are on number 34, which was the warm-up from Friday. Question number 34 was, what are the different ways to use biomass for energy? And we got to move quickly so that we can finish catching up with the other periods. And when you talk about the different ways to use biomass for energy, please make sure that you are clear about the outcome. So if you burn biomass, what do you get?
Heat.
Heat.
And light. A little bit of light.
What about if you digest biomass? Then what do you get?
Heat and energy.
Which gas?
Methane.
Methane. What could you use with that methane? What could you do with it?
You could burn it.
You could burn it to heat your house, or
Make cows go.
you could, somebody said it back there?
I said light your carts on fire. Is that?
No. What else could you do with methane? You could heat your house, or
Sorted and jarred.
Oh, make steam.
yeah, exactly. You could run it in an electrical power plant. That's about 8 or 10% of Los Angeles electricity. They get it from methane from landfills.
That's what percent?
So you 8%, I think. You could biomass to household heat by burning it. You could biomass digestion to household heat by burning the methane. You could biomass to electricity by putting the methane into a power plant. What else can you make energy from biomass? What about cars? Is there a way to run cars with biomass? Yes, like which biofuels? Vegetable oil into biodiesel, and also
Ethanol.
corn fermented to alcohol. That's right. So you could corn ... ferment ethanol transportation fuel, or biomass oil biodiesel transportation fuel. Are there any questions about those? Then number 35. Has anybody here ever been to a hot spring or a geyser? How do those work? How do they work? Yeah.
The hot spring I went to was like, you drive up into the mountains, pretty far in Idaho, and there's just a stream, and one part of the stream, there's just this hole in the ground, kind of, and really hot water shoots out, and we built this big wall around it, so we just trap it.
Yes, that's how the swimming in the hot works.
Okay.
But how does it spring hot? Like, how does it come out of the ground hot?
Ew.
Lava heats it,
Kind of, not
right?
really.
Is it sulfuric?
Sometimes, but not necessarily.
I was going to ask you if it had to do with sulfur.
Because I went to Hot Springs and there's like these like sulfur caves right here and just like all around it.
It's not necessarily the sulfur.
Oh my god.
But you know, because that water often settles in places without oxygen, and then it's circulated, you get a lot of anaerobic digestion sometimes. Yeah?
Does it have anything to do with like pressure?
Well, yeah, I guess. But pressure is just a function of heat. So where does that heat come from?
Since you said it was anaerobic,
Cold air.
since you said it was anaerobic digestion to create methane, and that methane is.
Wow, very interesting guess, but not even remotely close, no. But that was a very creative idea.
Well,
Luke was the closest.
There's something to do with like shifting of like plates or something that creates pressure that makes heat that like.
Oh, kinda. You and Luke are both flirting with it. Yeah?
just heat from the interior of the Earth.
Well, not the interior, but I mean not the center, but the. Does this help you? Atta girls. Yep. It was simultaneous. When I went like this. Magma. There's these things called tectonic plates. They're like dried up potato chips of crust, moving on a very thick layer of molten rock called magma. It's basically what lava is, basically. But keep in mind that when lava comes to the surface, it cools. Lava, by definition, is surfacing or surfaced magma. And so it's got something to do with magma, but it's not the lava itself. Quick review, you must know these terms. What kind of plate boundary?
Convergent.
Transform. Divergent, convergent, transform. Okay. If you look at the map just beyond Sam's head, that's my tectonics map. You should check it out sometime. It's kind of amazing. It has little white arrows to show you how quickly and which direction the plates are moving. Sort of neat. And you'll notice that just out of view, there's all this action happening on this diagram. That's called the ring of fire. It's basically here, and then it goes around there.
Cool.
This is going to be a lot of content all at once. Get ready. Like splitting a scab, when the divergent boundaries move away from each other, juicy stuff comes from underneath. That's magma that forms new plates, just like splitting a scab will form a little ridge of fresh scab.
Great analogy.
Everybody here's had a scab. It's a good analogy. I know it. Scab juice. Magma.
Magma scab juice. Yep.
Next. If you're making new plates under the ocean, somewhere else there must be a plate going underneath another. This, please look up, is a convergent boundary, and this is the coastal mountain range. Where two plates collide, you usually get a coastline with mountains. And now watch these hands. The plate that's being driven down is melting. And because there's all that extra magma, sometimes you get little burps of magma that are volcanoes, like Mammoth Lakes. Those burps of magma, if they break through the crust, there's so much and such a weakness. That's what we call a volcano, and lava would flow, which is magma coming to the surface. However, keep in mind, all that friction is also weak weakening the crust, like grinding your teeth. They kind of chatter against each other and crack. So even though volcanoes are not that common, there are a lot of places where the magma is not coming out, but there will just be a thin spot in the crust, where the magma is a little closer to the surface than others.
And that heats up water.
And when water soaks in, it heats up, and because it's hotter, it expands, because the heat equals pressure, so that water, by being heated, will rise, goes down cold, gets hot enough to rise. If it's driven by steam, then it'll go to steam and then go poof. Those are geysers. If it's not quite driven to steam, then it'll just be bubbling down below, and it just kind of comes out as hot water at the surface. Those are hot springs. Yeah?
So eventually you get back into it, is that not possible?
Not possible. I mean, you could, I suppose, someday, if the thing keeps weakening, if the crust weakens enough, you could potentially have a volcano there. But you don't have to worry about that. They're like very distant issues in geology.
It doesn't just happen. Like it doesn't just all of a sudden.
You're sitting
You're trying to say like it doesn't just like
Probably not very much, right? It's not like hot springs are like a step away from volcano. No. It's not like every hot spring is just getting ready to blow. No, you can chill out. So right over there, the Montecito Hot Spring. You know that we have a transformed plate boundary, right? That our coastline with the Channel Islands is basically going out to sea. So we've got this like thing going like that right along our coastline. So like if you follow the Ventura Santa Barbara County line, like along the ocean plate is going outward to the sea. And where it rubs against this coastal one, they occasionally chatter and weaken the stuff. And there was a creek along the Hot Springs Trail at the very top there, where that creek is kind of making a thin spot in the crust. And because there's some cracks down below, the magma's a little closer, and there's a place where cold water percolates down to that heat and rises, and that's called the Montecito Hot Spring. Are we all cool with all this? Now here comes the part that I find more interesting. Imagine you could find one of those thin spots in the crust where the heat is near you. If it's not too far down to the hot stuff, you could just push down cold water, and you could get heated water from the earth. That's called geothermal energy.
Does anything like happen to the water?
Depends how you handle it. If you just had a pipe that ends down below, you're basically just making groundwater. If you have a pipe that turns around and then comes back and it's open, then you're probably just making steam, because it'll boil in the pipe and just sort of come shooting out as steam. So if you pressurize the cold water going in, you get geothermal coming out, steam, and then you can actually run a power plant with that. But it takes a lot of energy to push that down. So what we usually end up doing is there will be cold water coming down to a hot pipe coming up that never opens. And then you run that hot pipe as the heat source inside of a giant pool, and that makes steam. And then you take that cold water and you put it back in the ground. So it gives up its heat. It's the heat transfer cycle. So you're pushing down cold and getting it out really hot above boiling temperature, but you keep it compressed. So you're running a single pump with pressurized water, and the earth is adding the heat that will make the steam. Yeah?
Why would we find your homes?
Well, because most of our homes are not on top of spots that are hot enough. Unless your name is George W. Bush, by funny coincidence, his ranch in Waco, Texas is heated by geothermal water. He happens to be on top of a hot spot, and so he's got his internal heat comes from a geothermal heater.
Isn't he just the environmentalist?
Isn't that amazing? Yeah. Go figure. He's got like a very low carbon home. Fun fact. Liberal whiners like me may notice some irony in that. So you guys, before you all break away to have different conversations, there's only one place on the planet where divergent boundaries occur on the surface. Anybody know which country that is? Anybody other than Welch? Henry Welch?
Iceland.
That's right, it's Iceland. Iceland is this little place right there. God, my hand shakes a lot.
Getting old cat runners.
It's a crack.
I thought my hand was fairly stable.
Might be those drugs.
Okay, anyway.
It's the mushroom.
Iceland. James Mel didn't believe it, so he had to look it up. Is the only country that has a divergent boundary at the surface. Coincidentally, fun fact about Iceland. Do you guys know that Bjork's mom and dad would tell her, like, sorry, we can't watch you right now, and she'd, like, go wander around outside by herself and sing to keep herself company?
Oh.
And so she, like, basically developed, like, spontaneous, childish yodeling as a kid. And so she built her amazing, massive, bottomless voice by yodeling out of boredom on her walks as a child. And so coincidentally, all of her songs are set at a cadence of roughly 90 beats per minute, which is your heart rate when you walk. Right? Nobody else is interested in that? You're the worst people ever.
You're kind of weird.
She's good kind of weird. She's a fox weird. That's the good kind. That's the good kind. Yep. That's what I'm talking about.
Oh yeah.
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 That's the good kind. All right. Oh, another Bjork fact. You must all watch a movie called Dancer in the Dark.
Oh yeah.
It is, and it's really obscure, and it's really amazing, and it's really weird. Is it a Jim Jarmusch movie? You were just there, weren't you?
Yeah, I didn't know who it was, so I looked it up.
Oh, dude. Okay.
Are you obsessed with Bjork too?
Every man with good taste is obsessed with Bjork. It's a fact. Yeah. Are you obsessed with Bjork?
No, but I just.
You don't have good taste.
Yeah, you did, dude.
It's a behavior you can learn. All right. You can acquire good taste. Just don't worry. Was it Jim Jarmusch?
Which movie was it?
Dancer in the Dark. All right. Wait. I wasn't bringing up Iceland just because of Bjork. I was bringing up Iceland because keep in mind, that's a place where the magma is literally at the surface constantly. And that's a very big deal.
Yeah.
Because today, Iceland is about 98% carbon-free electricity.
Yeah.
And they're working on a project to lay a giant copper cable all the way from Iceland to the United Kingdom, Germany, and France, where they plan to start selling electricity to the European Union, and in your lifetime, Iceland will become the planet's largest energy exporter.
Beneficial.
They will beat the United States, and they will beat Saudi Arabia, and they will beat Russia in the next decade. And get ready for this, carbon neutral electricity, not fossil fuels.
America. I mean, Iceland.
That's what we call winning. Yeah. Icelandic. Yes.
Wait, doesn't this like cool down the earth, man? And the earth's
Yeah.
gonna go cold.
Yeah. It's relatively irrelevant, though.
Like it's not gonna really affect anything noticeable.
Some nerds have talked about like some nerds have talked about like changing the temperature of the crust would be a really big deal. But basically the energy dynamics that you're talking about are like 1,000 zeros and 1,000 decimals, and so like, not really in any significant way, but like in very local. You know, if you take away the heat from the crust, you're basically affecting its frictional coefficient. And so, like in tectonically active areas, people are like, it's going to cause an earthquake if you're like shrinking this crust and letting this one stay expanded or whatever. But
Nah, don't worry
It's
about
too moot. It's totally moot.
We don't.
Alright. Tim Jarmusch?
it. As long as it's great time.
On Trier. Yeah. Alright, kids. Did you all like my Iceland will be the largest energy exporter in your lifetime?
Yeah.
Fun fact, right? Yeah. Electricity. Carbon-free electricity. Oh, by the way, Iceland has like some of the most profitable aluminum mines on the planet. And it's not because they have good aluminum or because the mines are especially good. It's because they don't have to pay for the energy. So it's like a giant shipping hammer. Why not? And so they can just do like extremely inefficient extraction because all their energy is carbon-free. I know.
Jose likes this.
So check this out. Jose loves Iceland.
The island's cool. It's got like.
So if we've got all of this amazing sustainable energy potential, how are we supposed to decide? How will we choose? We're drowning in good options. It's like you've got a bunch of good food at your house and it's all going to waste.
Let's
What are
just
you going to
do
eat
clean
first?
coal.
So these are some facts you should know and maybe write them down, but you'll have to go quickly. First of all, nobody wants to waste a lot of money and risk is bad. Second of all, if you don't have papers ready, I have no compassion for you. Second of all, supply must always top demand. Our grid does not have storage. So we need to always make more electricity than people are using. We've got to always be ready to out-supply the public. Do you all know what happens when you've got more demand than supply in electricity?
Blackout.
Those are blackouts. And if you got grandma on the ventilator, that's really serious. So blackouts are, by the way, no joke, no exaggeration, truly a matter of life and death. And you know, you cannot make all of our electricity with solar panels in Arizona. That's too far for most of the planet, for most of the country. Electricity production has to be local.
Yeah. So how is the Iceland thing gonna work?
Well, there it doesn't matter because there's no carbon cost to the waste. So when you look at that cost, if you don't want risk, fossil fuels are the best choice. If you always need more supply whenever you want it, fossil fuels are the best. If you need energy that can always be kept nearby, fossil fuels are the best. And nobody wants the stuff in their backyard. All of these renewables are really visible. Like a bunch of wave energy generators on the coastline, that's really visible. A bunch of wind turbines up on the ridgeline, that's really visible. A bunch of like solar mirrors and solar panels in your landscape, those are really visible. You know, one of the beautiful things about fossil fuels is you can kind of hide them. All the fossil fuels come from the place where other people live, not my problem. And you can squeeze the natural gas plant or the coal plant, wherever you can squeeze it. You can hide that stuff. Fossil fuels are really winning. And by the way, there's no such thing as a free lunch. So everybody can always point out how the wind turbines are killing the birds, and everybody can point out how the solar reflectors are paving the desert. Everybody can talk about how the water stuff is hurting the ocean diversity. It's not like they're free. And so basically, fossil fuel is winning. It's hard to beat. For now.
For now.
Yeah, that is, Hugo knows, a big but.
Of course, Hugo.
Carbon tax, yeah. Oh wait. Beyond.
Because what if we had to pay for the CO2? You know, your mommy and daddy have a credit card, and the bills aren't being sent to your mommy and daddy's house. They're being sent to your future residence. I get to go shopping with a credit card, and I never see those bills. My daughter and her children are going to get that bill. I come home, and I'm like, look at all this cool stuff! Didn't have to pay for it! And my daughter's like, Dad, I think I'm going to have to pay for it. And the answer is correct. That's right. That's how it works. We've had a couple of generations of fake economy. Nobody wants to quit because fake economy is really nice. There's a giant cost that we don't have to pay. You'll pay it. We don't have to. We love this economy. You hate this economy. We love the fake economy.
Who's this economy run by? Adults.
Exactly, loser.
Yeah.
We'll just keep raising the voting age until we all die. That's basically my plan. Yeah. When I become president, we just bump it up every couple of years. Ha ha. You really you got to notice that I'm being like kind of facetious and sarcastic, but also ironically accurate. And this is exactly the truth of the situation. There is no doubt that global warming will cripple your economy. And we're not paying for that. It is undeniable that global temperatures are going up faster than ever, currently higher than they've been in a very, very long time. It is undeniable that sea level is rising. It is undeniable that food production will be strained. Natural disasters will go up. Disease will spread. The majority of the biggest cities on Earth are all on the coastline. What could possibly go wrong? And so when we have to pay for CO2, all of a sudden in the equation, the renewables win and fossil fuels lose. Until then, operating under our fake economy, fossil fuels are our future. Notice I said ours, as in the old people living in the fake economy. Yes?
You guys are going to die.
Who cares? You clean up the mess. Then you die. That's like telling a coke addict, like, you're going to die. Like, I don't care, I'm going to die on coke. And look, I thought before I went I would show you a neat little detail. This demo should have been ready earlier, but I was in a hurry that day. Solar panel runs an electrolyzer that splits water into oxygen and hydrogen. You hook up the hydrogen to a hydrogen fuel cell, and hydrogen gas becomes electricity that does work. I want to remind you that one of the things we talked about was not an energy source, it's a method of energy storage. It's not like a battery where you're like storing electricity. Well, it is just like a battery. This is the battery, where you're making electricity into chemical potential, and then you're translating that back to electrical work.
What are you doing there? Making
I'm shutting off the hydrogen. This is my hydrogen gas reservoir. This is my hydrogen tube. And this is my thingamabobber.
Okay.
When I open the thingamabobber, hydrogen comes to the fuel cell and makes electricity. This is the basic secret that we need. In a large scale for renewable energy, The fundamental obstacle is we got to find a way to store the energy. You can either store the heat, or you can use electricity to make hydrogen, which you can store. But for all these renewables, we got to have a way to store it. You can pump water uphill and then let it out through the hydroelectric plant. But one way or another, we got to store the energy. Storage is the secret to the grid of the future. Thank you, TAs, for making me this demo.
Yeah, it was all Daisy.
All right, Davey, thank you for making my demos. Anybody want to talk more about renewable energies? We're still not catching up with my other periods. Then please take out your 7.5. You're not done. Taylor, how's your nose? Bruising, marking? Anything visible? Yeah, I'll make it burrito.
That was my space.
It needs to be coming.
Sweet. It's the date, dude. It's the date. Wrapping aluminum back the poster. All right, you go. Party time. Yeah, but you should have heard the sound it made. I was thinking like broadside, like a big flag of cardboard, and right when it came to her face, like the top edge bent down, and it was like the sharp edge, and made like a really loud sound. I thought it went into her eyeball. It was like perfectly aligned between her eyelids. Isn't it amazing that your brain can do that?
Yeah.
Do you realize that your eyes close before your brain knows they did?
Yes.
Okay, now me.
Look at evolution now.
Now me. We are about 15 minutes behind my other periods. Is there any vocab in the nuclear energy one? Yeah.
Pebble-fed reactors.
These are nuclear reactors where the fuel is in small pebbles. Yeah.
Passive safety.
These are reactors where the safety measures are automatic. It doesn't require human action. You can visualize the reactor above a giant pool, so when it melts, it falls into a pool of coolant on its own. That's an example of passive safety, where humans are not required for the safety measures. This is the ongoing nuclear reaction, and I'll be able to show you that tomorrow. It's a continual reaction, like a positive feedback. What else? All right. Before we start talking about nuclear energy, I got to give you a band-aid of chemistry. Remember that a lot of you come from different backgrounds, and even if you took chemistry, a lot of you forget some really fundamental basics. So I want to get everybody back up to speed with some fundamentals. You'll probably want this on a separate sheet of paper called the Fundamentals of Chemistry. Unless your name is James Bell, in which case, go on with your cell phoning and clear your desk. All right. For your fundamentals of chemistry, there are 3 parts to the atom. Today's warm-up, what are those? Proton, neutron, electron. And their charges are?
Neutral, negatron.
A proton is positive, a neutron is neutral, an electron is negative. And the most generic model to describe how they fit together is protons and neutrons in a nucleus with electrons flying around. Maybe in rings, which is a good metaphor but not accurate spatially, or maybe in clouds of probability, which is a good explanation but not a good way to visualize them.
So there's basically kind of like orbit in this probable area.
Yep.
Do they have the same orbit every orbit?
No.
It's kind of like.
But each electron is usually within one of those clouds. So please look up P for positive, N for neutral, E for negative in a nucleus, in clouds, or rings around. Yeah.
Wait, what's inside of it? Did you say, is the inside the thing, is it just P or E?
Protons and neutrons are in the nucleus, electrons are moving around.